Welcome, guys, to today's session. Today we'll be going through 2021 semester test 2, the afternoon paper. So let us begin. So the Utopian Electoral Commission is preparing for the upcoming selection. Utopia has a two-party electoral system with citizens only being allowed to vote for either the Utopian Authoritarian Party or the Authoritarian Party of Utopia. So you can either vote for one of the two. You can't vote for both. As seen by the or stated there, the commission is interested in conducting various analyses about the voting districts to identify potential problem areas and also to allocate staff and resources. Due to recent introduction to anti-gerrymandering laws, all voting districts are uniform squares and have been projected onto a two-dimensional grid. Each voting district within the grid contains the following information. So the first thing we should take note of is each voting district within the grid. So remember that we have a two-dimensional grid, a two-dimensional grid or a two-dimensional array of voting grids. And what they're saying here is that at each coordinate, at each XY coordinate or row column coordinate, each of those values will be represented by this information that I have here. So this is a this this is a form of a data structure. So I must pick the right data structure applicable to the scenario. As you can see, we don't have any functions listed here. So it rules out the class keyword. I don't have to create a class. If it had methods or functions, then I would have to use a class or create a class. But since it's only just data, it's only data. That's all we are storing for each voting grid. I will use a record structure. I'm going to use a record structure. So let me create the project. So let me give it a name. The science one be 2021 first paper, and then afternoon. Then it goes while it's building. Let's check the question paper. So we have district ID, that's the first thing, and it's a pair of integers. So it's a pair. So that means I must define a way, close. So that means I must define a way to exit. So that means I must define a way to group this data to represent one thing. So that's another data structure that's required here. And as you can see, it's a pair of integers, each integer greater than or equals to 0. So it's a pair of integers and each integer has to be greater than or equals to 0. By greater than or equals to 0, it means that it's unsigned. It's positive. I hope it doesn't give me any issues. But when they say it's greater than or equals to 0, remember that greater than or equals to 0, it's 0 to infinity. That's what it means. So 0 to infinity is what? Positive numbers. And how do we define positive numbers in a language? The numbers that, remember that the number that you can represent, it can be stored in a data type, in a variable of a certain data type. So since it can be stored in a variable for certain data type, I need to use what we call modifiers. I'm going to call them modifiers because they just modify the current data type. So we have two keywords. We have signed and we have unsigned. These are the two keywords. Signed means that it accommodates both positive and negative values. In essence, it's from negative infinity to positive infinity. In a way, you can view it like that. But it's not necessarily infinity because, yeah, it's a restricted. It doesn't go to infinity. If you want to be, if you want to be, uh, if you want to be accurate, remember that integers store 4 bytes, which just translates to 8 times 4 because each byte represents 8 bits. So this translates to what? 32 bits. And the possibilities now is that the possibilities is now that if it's signed, it basically goes from negative 2 to the power 32 minus 1 up until positive 2 to the power of 32 minus 1 plus no, yeah, minus 1 and then everything subtracted by 1. So it's somewhere around, if I'm not mistaken, somewhere around 4 billion, somewhere there. That's like roughly the range of numbers that you can represent. Here, I think it's going to be negative 4 billion. And then up until like positive 4 billion. That's the integer equivalent value that you can represent. So yeah, then here you're going to have unsigned, which means that unsigned, it means that it only stores positive values. That's what it means. It only stores positive values. So you can use these keywords to modify whatever, but let me explain in simple terms, starting with the predefined data types. So let's look at integer, float, and double, right? The numeric data types or data type that represent numbers. So with an integer, with all of these numbers, all of these data types, they are signed by default. They are what? Signed by default. All of them are signed. That means they can accommodate both positive and negative values by default. So you can, if you want to, you could be explicit and put the keyword there and say signed int number. You could do that. You could be explicit and be like, okay, it's signed. But by implicitly, it is signed by default. Let me show you an example of this. So let me say int number is equals to 0. Let me say -1. Let's start with -1. And then there's the number, and then I think it's shift. Okay, let me just press, yeah. Okay, Control Shift F10. Okay. Come on, build. There we go. So there's -1, right? It does display the -1 value to the screen. I can also store a positive value. I can also do that. So let me run it again. There we go. There's the 9,000. So you can store both. So you could also technically be explicit and say it's signed, but by default it is signed. You could do that. You could be explicit and say it's signed, but by default it is signed. it's not going to change the way your program has been working because we already knew that it's signed. It works with both negative and positive values. So there it is. There's this load signed. So the way I like to view signed and unsigned, right? So remember the term sign. What does it mean? There's a stop sign. There's a plus sign. There's a minus sign. You see, sign, 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 sign. So when you say it's signed, you are saying that it has symbols. It has a sign. Remember that we don't write let's say for example when you're solving for x in math, you don't say x is equals to plus 3. You don't do that. We always drop the plus. That's the rule, right? So we're calling it signed because for negative values we need to put a sign there. So that's why we're using signed. When I say it's unsigned, unsigned, okay, unsigned, come on, unsigned int value. When I say it's unsigned, I'm saying that it doesn't have signs. It's unsigned. There's no sign. What is the sign that we usually put? It's the minus. So when it's unsigned, it means that it doesn't have minus. It doesn't have negative values. It can't store negative values. So let's try to build and run it like this and see what happens. You see, oh, okay, it didn't. Let me see. Let me try display. Yeah, let me do that. Yeah, you see, that's the property of unsigned. It doesn't work with negative values. So what happens is that, you see, like I said, it's around 4 billion. That's the maximum. So what happens is that it converts this to the integer maximum value, or the maximum value that an integer can store. To confirm that, you're gonna do this. You're gonna say, you say what again? Okay, I just use an integer and say max. Wait, how do I do it again? Yeah, int max. Yeah, it's called int max. I want to show you that these values are indeed similar. So that's what's going. Okay. Or for okay, it's around 2 billion if it's signed. Yeah, it's around 2 billion. And then if it's unsigned, it's around 4 billion. So I'm gonna say u int max. U stands for unsigned. Remember that we were trying to find out why it's displaying a value of roughly 4 billion on the screen instead of negative 90. So there we go. You see. So what it did, if you check this properly, the the thing that it did is that it's sort of like it subtracted the 90 from the maximum and just returned the maximum, because what happened here is that you tried to surpass the maximum that an unsigned integer can store, or the value that it can store. It can only store positive values. So now it doesn't know what to do with negative values. So when you use unsigned, just know it's unsigned. There's no signs. There's no negative sign, minus sign, because we don't represent plus. We don't put plus sign. We don't say plus 90. We just always say 90. So when it says unsigned, just know there's no negative sign. There's no sign. There's no sign at all in the number. Just keep that in mind. So that's something that I just wanted to explain. So you can be explicit and say the value signed or unsigned, but by default it is signed. That's why we usually omit that. And another trick is that unsigned, C++ takes that as a different type of an integer. When you say unsigned, it's some type of an integer, so you can drop the int because it already knows that it's an integer. You don't have to explicitly say it and say unsigned int. You can drop that. You don't have to do that. It's gonna work the exact same way. It's gonna work the way it should, as you can see. And as you can see now, since I've changed the sign, I've removed the sign, it outputs the correct value. So I'm gonna use this format. You can also use this format and say unsigned int to remember that it's an integer. You can do that. It's perfectly fine. But I'm just gonna leave it like this and just say unsigned. So yeah, we have that figured out. So now we know unsigned, when they say it's greater than or equals to 0, as you can see, it starts from 0. So that means it's positive, it's unsigned. And you can also have any unsigned value. You can have unsigned char val. I think can, yeah, an empty space, whatever. So you can have an unsigned character. You only look at characters that where the integer value is positive. Yeah, because the character is some type of an integer. Since at the fundamental level, information is stored that is stored on a computer is translated into numbers, into binary zeros and ones. So at the fundamental level, it's just numbers, it's just integers. So you can also have unsigned double DVL value. You can also have that. Oh, okay, you can't. Oh, yeah, you can't. Yeah, you can't have. I remember you can't. You can only have unsigned for integer, and then double. Yeah, it just works the way it is. Yeah, you only have for integers, so we're gonna apply it here with the pair of integers. So let's break this thing down. You're gonna need to create some sort of a data structure to represent a voting grid, right? That data structure, it depends on the information that we have. What information do we have? We only have data. What data structure is perfect if you only want to represent data? It's a record structure. So we're gonna use a record structure to represent the voting grid. And then we're gonna need another record structure to represent the district ID, because this pair of integers, it's a pair. So these two values represent one thing. I can't declare them separate. I can't do this. I can come here and say struct and then say voting grid, right? And then I'm gonna say int row int, or I can do that. It's this what this means is that it's part of the voting grid. I need to find a way to combine this thing to represent one thing. And I can do that by a means of a record structure. So let's create the file, the header file for this. I just need to know which class, what is the class of the name that's going to use voting grid. Oh, it's a voting district, I think. It's not voting grid. Yeah, it's called voting district. So voting grid is the class. That's the grid, yeah. The grid for voting, yeah, makes sense. It's gonna have a two-dimensional array of structures to which I store the data. So yeah, I'm gonna store the voting district. I'm gonna create the voting district inside of, what is this? Um inside of voting grid. So that's why I'm gonna start by creating the header file and the source file. And then, okay, I don't need to do that. I just need to say new C++ source file. And then, yeah, there we go. And then I'm gonna say, I'm gonna write my name here. There we go. So also pay attention to what we call preprocessor directives. There's hash if and def, hash define, hash and if. All of these preprocessor directives, what are they? What do I mean by hash define, hash and if and def? So the typical procedure of a C++ program, how it gets compiled. The first thing that happens is information is processed by the preprocessor. Preprocessor. So this happens before compilation. Before you compile the code, your code gets sent to a preprocessor. So what is a preprocessor? Preprocessor, all it does, it provides meta information about your application. So for example, what do I mean by meta information? So what is an int? What is unsigned? What does that mean? What does double mean? What does return mean? What does the uint max mean? All of that is processed by the preprocessor. That's why we have preprocessor directives. So it's instructions that need to be executed by the preprocessor before we run our code. Because if we don't do that and we just run this, we don't know what int means, because int is stored inside a library, the IOStream library. All of this information is stored inside libraries. So we need to tell the preprocessor to, let me see, can't I go to the declaration definition? Yeah, there's the definition. I wanted to see the code. Okay, so as you can see, some of the things are here, some of them are not here. We have the cin, the input stream object, the output stream object, the standard error stream object, and the buffered version of the error stream object. And then we also include other streams. We have, this is the file. So it has all of this information about the code. Why did we use int? What does int unsigned mean? What does double mean? All of that. It has all of that information. So that's why it's able to know, oh, okay, I need to output what here? I need to output 90. What is 90? It's unsigned. What is unsigned? It's a positive integer. How does it know? Because it's inside the IO stream. And it's also inside the standard namespace. So that's the whole point about preprocessor or hash statements. They get sent to the preprocessor. We call them preprocessor directives, which is something that needs to be um, something that needs to be um, handled by the preprocessor, so that the information, the code that we wrote, the ints, the double, those keywords, those words that we have in our code, they have meaning. It will know what they mean, so that when we are building a file that contains the right data. It contains doubles, it contains integers, it contains all of that. So that's the first part, right? That's preprocessor. So what are these different types of preprocessors? So we have this preprocessor to define something, to define something. You can use, what define means is that replace all, you can have this format, you can have define key value. The key is some variable. So I can have size, call it size, and then I can have a value, call it 900. This is how you would define constants in the C language. So that's another way you could use the preprocessor directive. You define. So what this means is that replace everywhere where you see size with 900. Replace that with 900. So that's why you are able to do this, and you use a for loop and say int I blah blah blah, and then you say it's less than size. How does it know size? Because you have defined it. That's what, there's different preprocessor directives. They do different tasks. This one define is to define something. It's in the word itself. And then we also have the normal ones. If not defined, what what this preprocessor directives do, the end if define, if not defined, what they do, their main purpose is for you to avoid repetition. So it makes sure that what this means is that if not defined, that's what it means. So what this first statement means is saying if this header file is not defined, then what should happen? Define the header file. So you see, we avoid repetition. So it's not necessarily repetition, but secular imports. So when you're including something multiple times and then you include it in a secular way, it avoids that. So that's another error that might arise if you don't include your your header files in the right way, or you include them in a secular way, whereby you include and include. It's already included, but you're including again, but in a different file. So it avoids you having to do all of that. So if you do that, it's gonna shout at you because you have this statement. It says if it's not defined, then define. If this is not defined, then define it, and then end the definition. And if so, stop. This is where it stops. So define what? Define this that I'm going to write in between here. What is that? It's my record structures, my information that I'm gonna use, the types that I'm gonna create, all of that goes in there. So let's create our record structure. Let me not spend too much time explaining these preprocessor directives. Okay, let me do something. Yeah, let me show you a simple example. So I'm going to define a constant, right? So define size 100. And then I'm going to include the, what is this? The voting grid.age. And notice the square, the greater than symbol, the less than symbol and the greater than symbol, and the double quotes. What is the difference? The difference is that with this first notation, this one, what it does, it looks in the standard libraries first. Standard library first. That's where it starts. And then it looks into your project structure. It looks into everywhere where it can find this file. Did it find it? If it found it, then it's gonna send it to the preprocessor, that information. So that's what the first notation does. The second notation, however, it says start by looking in my project structure, then look into the standard library. What is the standard library? It's the library that everything about C++ is stored in. That's simply what it means. So that's what I'm saying when I say standard library. I'm saying that this is gonna be looked at in the C++ language first, because either way, that's where it is, right? I don't want to waste time by starting to look into my project structure. And let's say for now you're making very small projects. Let's say everywhere inside of this panel, it's full of files. There's folders within folders, files within files. It's complicated. It's gonna be time consuming. So it eventually makes your application very slow because you're spending unnecessary time looking for something that's not, you know, for a fact it's not in your project. So that's why we always use this notation to include libraries that are in the C++ language. And then this one to include the information that we have defined ourselves, the header files that we've declared on our own inside of our project. So we can do that. So I'm going to show you other preprocessor directives. I'm going to say hash if defined. I think, what is it? I think it's size. And then you have and if, now you have elf, or you can also have, at the end of the day, I'm going to need to end if. So if defined, what am I saying? If this is defined, if the size is defined, then what should happen? I should see out the size. That's what I should do. I should output that value if it is defined. Then we have hash else if or elif. Then else if, that means else, or you can, I think you can have, let me see. Do you have else? Yeah, you can use else. So else means that it was not defined, right? Else, then output not defined. I'm not sure if I'm using it the right way. Okay, let me just say else if. Oh, okay, it doesn't change. Okay, that's fine. Let's see. But this is another way you could use it. As you can see, it's working. It did work. So what I'm simply doing here is I'm saying that I'm using the preprocessor directive to check if is defined, if defined, if def means if defined. What is defined? If this is defined, I'll put it to the console and it is defined. Else, I'll put what? Not defined. So let me comment that out. I don't think it should break. Let me see. I don't think it should break, yeah. Because with preprocessor directives, it's not like variables. It doesn't work the same way as variables, as you can see. Now it's outputting what? Not defined. So yeah, this was the way to work with some few things in C. And then C++ changed all of these things, improved it. Because if you made a constant, remember that, like I said, this was the way to make constants. You make a constant like this. This is not safe. I don't know, for some weird reason, defining macros like this, we call them macros, it would create some errors. Unexpected errors though. It's not like an expected error. It's like an exception. There was always exceptions with this. So they had to improve it and they changed it to this. I'm sure you're familiar with this, static const int or static const expression. And then you say whatever, let's say it's pixel, whatever that expression is. It can even be a function, it can be an expression. So yeah, that's what these things mean, all of these preprocessor directives. So now since we have a bit of an idea of what's going on in C++, now we can start coding. So I'm gonna have the first record structure, which is the district ID. So there is the district ID, takes a pair of integers, row and column. So district ID, I'm gonna name it like this, district ID. And it's gonna have two values. And remember that they said they're greater than or equals to 0. So they're from 0 to the maximum that an integer can store, specifically an unsigned integer. So we have to use an unsigned integer. So I'm gonna have row here. You can call it int row, but to be honest, this is like an outdated version of doing it. Yeah, it is outdated in the industry. This is an old way of declaring variables. It was famous back then to declare variables like this and all of that. But I'm just gonna say row, unsigned, column, and then done. I have my district ID. I have my data structure there to represent only the data. So let's see, it must be unique. No two districts can have the same combination. We need to keep this in track, keep this in mind. Yeah, they need to be unique. Let me see. I think they just that forgot. Let me see. Okay. I think it's in a earlier newer version, if I'm not mistaken. There's some keyword that's related to that. Population. So population is, okay, now we are inside okay, we're done creating this data structure. So now we need to create the data structure for representing the voting district. So struct voting district, right? Remember, before we continue, we must include the district ID, that type, and then it's gonna be district that represents the district. And then we're gonna have the population, which is an integer value greater than or equals to 0. Again, it's unsigned. If you don't do the right things, then yeah, it's gonna be a problem. Remember, if I just write it like this, like that, it means the same thing as unsigned int. That's what it means. So I don't have to be explicit and write it there. But for the sake of getting used to the data type, I guess I'm gonna just put it there so that when you guys read my code, you understand what's going on. I was just gonna put it there, but there's no need for it to put it there. Population, right? And then a real value, that's a double. It's a UAP support percentage. So it's a double value. So double UAP support. Yeah, I'm just gonna call it UAP support. And then another double value. So what I'm going to do is I'm just gonna write the range so that I don't forget when I'm implementing my code. APU support. I think it's APU, right? Yeah, APU. Then we have undecided. Undecided, right? So double, I'm just gonna call it undecided. Yeah, I'm just gonna call it undecided. And then, yeah, all of them are in that same range. They're from 0 to 100. So there we go. We are done with our data structure. So it must be in a voting grid, and then voting grid can be analyzed in what, blah, 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 blah. Potential fraud. This is the implementation of the voting grid. So we don't have to worry about that yet. We need to come back here, come down here, and then check what we actually need to do, how we need to declare the class and everything. So we must create the class to represent the voting grid. So we must create a class to represent the voting grid. So class voting grid, there we go. And then we're gonna, the class makes use of principles of good design known to you. Yeah, basically constructors, public, access modifiers, private, protected, all of that, polymorphism, yeah, all of that. It must additionally make use of a dynamic two-dimensional array of structures. And where did we see that? We saw that at the top there. You must create a system which will generate a two-dimensional data structure which stores the related voting districts in a voting grid. So that's the type of the data structure of the two-dimensional array that we're going to create. And it's going to be what? Dynamic. So we're going to use pointers for this. So let me do this. Why does it always go back to the beginning? I want to do that. And then private. So yeah, remember that by default, the way we declare represent data, the way we represent data in a class, everything should be private by default. Then we use accessors and accessors or getters and mutators or setters to determine what things can be accessed, what things can be mutated or changed. That's what good design means in this context. So we're gonna have voting districts, two-dimensional array. And then I'm just gonna call it votings. Underscore voting. Let's just call it underscore voting. That should be fine. Should make use of a two-dimensional array to store. We did that. The voting grid has a collection. Blah, 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 blah. Abstract base class. Blah, blah, blah. Blah, blah, blah. Given. Okay. They don't talk about a lot of things here. Like, for example, the constructors, they don't go in depth into that. And other information, like rows and columns. Remember, that's a two-dimensional array and it's dynamically allocated. So I need to have variables to represent the data, for the thing, for the dimensions, to represent the size for the dimensions. And remember, you never have negative column, column -2 or -2 column. You never have something like that. It's always going to be unsigned or positive. So we need to start using the things that we know. We can put in, and it doesn't stop us from creating helper functions. It doesn't. All I'm saying is just that we need to use the right type and not reserve memory for the values that we're never going to use. We're never going to use negative values, right? For rows and columns. So why make it signed? We need to make it unsigned. So I'm going to say underscore rows underscore columns. And remember, you can declare multiple variables of the same type by putting a comma. They're of this type, both of them, rows and cols. So we can do that. And then we're going to need to create a constructor, empty parameterless constructor. And then we're going to need to create a parameterized constructor. And this is the signature. It's going to take in two integers, unsigned integers. Two unsigned integers. You can also just leave it as unsigned. Like I said, it means the very same thing. But I'm just going to write it like this. And then let's not forget the destructor, because we need to deallocate memory. And then, is there any more information? Okay, for now, I'm going to leave it like this. Okay, we also going to need a copy constructor. That's what's always there. Constructor, destructor, copy constructor. It's usually destructor, copy constructor, and the assignment operator. Those are always there. So I'm gonna have const voting grid there like this. That's the signature. And then then that's all. For now, this is all. We won't need more information. For now, this is all. The voting grid class has a collection of one of each kind of voting analyzers. So it is one of each kind of voting analyzers, which implement the analyze method that will return a string representation of the grid. The voting grid delegates its own analyze method to the contained voting analyzers. The voting grid must manage the lifecycle of the voting analyzer object. So what you're gonna do is we're gonna need to create this class. Let me see, let me just do this. I feel like if now I wanted to create both, so I'm just gonna tell it to create a class. Because when it creates a class, it must create both the header file and a CPP file. There we go, problem solved. I don't have to create them individually. So we have the voting analyzer. So now I need to go to my header file. And then remember that they said it should manage the life cycle. So it's going to be voting. Okay, I need to, okay, let me just write it. Voting analyzer, and it must manage. When they say it must manage the life cycle, that means it has to be one dimensional. You need to make a pointer there. It's managing the life cycle. If it didn't manage, you would remove and just declare it like a normal variable. Since it's managing, I have to make it a pointer. And then I say underscore analyzer like this. And then obviously it's going to want me to import the header file so that it knows about the analyzer. What do I mean by voting analyzer? Where is it stored? It's inside the header file. That's what, remember, this preprocessor directive thing is very important. So that when you compile your code, it will know what voting analyzer is. It will be like, oh, it's a class. Okay, I know it now. You see, so that's very important. So it's going to manage its life cycle. So we're just going to create that. That's done. We'll write the implementation later. For now, we're just creating the blueprint of the blueprint of our code. So modify the previously created classes to use an inheritance hierarchy with polymorphism as follows. So now I must modify. Oh, it delegates its own analyze method contained in, and then they said it should represent, it should return. Let's analyze this thing. We must learn to read the question properly. So let's read this part. Implement analyze method that will return a string representation of the grid. The voting grid, right? It delegates its own analyze method to the contained voting analyzers. So we have our own method here, its own analyze method. So far, they just said it should return a string representation, right? So I'm just gonna say standard, then string like this. And then I'm going to say hash include IO stream like this, because the string is inside the IO stream, which is inside the standard namespace. But I can avoid writing all of this. I can avoid writing all of this. The string here, I can avoid writing all of that. How can I avoid doing that? I can either do it in one or two ways. I can say using, and then I say standard. What am I using? Standard string, like this. So I'm using the string that's inside the standard namespace, so that I don't have to, every time I write code, I don't have to say standard string. I don't have to do that. I don't have to do all of that. So, and the reason why I'm doing it in this way is that, remember, I'm not going to use the whole namespace here. I'm not coding inside the header file. I'm not implementing methods, or implementing the class. I'm just writing the blueprint here. I'm not going to use the whole namespace. I'm just going to use the the string inside the standard namespace, and a couple of things, but I'm going to add them as time goes on. So now I don't have to explicitly say standard std : I can just say string like this. Done. Straightforward, very convenient. It makes my code easy to read. Okay, I don't know why it keeps highlighting everything like this. Oh, it's complaining because I haven't implemented them. Yeah, we'll get to that. So we did create the analyze inside of our voting grid. Now we need to go inside the voting analyzer. So the voting analyzer with the string returning pure virtual function. So we need to go and create a virtual function inside of the voting analyzer class. So public, and then I'm gonna have a string. Yeah, and since I'm not going to use, let me think about this for a second. Yeah, let me just, okay, for now, let me just do it this. Standard string. And then I need to include IO stream. Then we'll stop complaining because the standard namespace inside is inside the IO stream. So I need to do that. And then now I can just say string, and then analyze method const, and then it should be a pure virtual function. So virtual is equals to 0. So when it's a pure virtual function, what that means, it means that the function is abstract. It's an abstract method or an abstract function. By abstract, it means that it's not complete. It's not implemented for. As you can see, I just say set it to 0. Just say it's equal to 0. It shouldn't return anything. It shouldn't have any code. So since this is an abstract method, technically this class becomes an abstract class because it is an abstract method. It is something that's missing or something that's incomplete. So it's an incomplete class. So since it's an incomplete class, I can never instantiate this class, an object. And yeah, I can never instantiate the class. I can never do this and say analyze, right, and say and what, and then I say is equals to new voting analyze. I can never do this. It's incomplete. You see, allocating an object of an abstract class type unimplemented. You see, you can't do that because when you instantiate an object, you're saying it's complete. Would you want to buy a car with no engine? Remember, a car is an object. Would you want to buy a car with no engine, a car that's incomplete? Or with a car that is an engine that's not complete, an engine that can explode at any time? Would you want to do that? No, you probably wouldn't want to do that. So with that being said, you can't instantiate, you can't create an object of this type because it's incomplete. It's not finished yet. The only thing that you can instantiate, it's an object that's complete. So let's remember that. So we have created the method is an abstract base class with a string representation function called analyze. It returns a pure virtual function called analyze. So there's something that we need to fix here before we continue. Remember that the voting analyzer, remember the voting grid delegates its own analyze method to voting analyzer. So what I need to do is when I point to the implementation of this function should take an object of that class, a reference to that class, so that it can what? Analyze for the voting grid, analyze on its behalf. So it needs to have information about the analyze. So as you can see, let's check what it's supposed to do. It is supposed to return a string representation of the grid. So since it's supposed to only return a string representation, it's not supposed to modify. I'm going to put a const keyword there because it's not meant to modify. Const, and then I'm going to say voting grid. It's going to moan at me and say, I don't know what voting grid is, but we're going to fix that. Reference. What is voting grid? I need to specify what is voting grid. So I need to say hash include. Remember, I don't want to use this notation because with this notation, it's gonna start looking for the voting grid inside the standard library. And the standard library is very huge. It's gonna waste time. So I want to start it. I want it to start looking into my project and look for what voting grid header file. There we go. The problem is solved. So there we go. It takes in a reference of voting grid. Then now what we need to do is create the child classes because that's everything we need to create here. Just an analyze method. That's it. Remember, I'm taking a reference of voting grid because I need to analyze on behalf of voting grid. So I need to make change. I need to output the information for voting grid. If I don't get a reference to voting grid, how am I going to output the information? Exactly. I won't be able to output the information. I need to get a reference of voting grid to be able to output the information. Then we're gonna have the child classes, and then that's gonna be pretty much it. And then I'm gonna pause the recording here. Yeah, I'm gonna pause the recording now. After creating this child classes, then I'm gonna make part 2 because I don't want to make it like I don't want to have a 4-hour long video. Yeah, I know the brain is very lazy. No one's gonna watch if it's 4 hours. So battleground analyzer. So this is the first class that I'm gonna create. The nice thing about having modern IDEs, I don't have to write everything from scratch. And you could also, I think you could also do it in code blocks. Yeah, most certainly sure you can. Let's just double check. I think you can. Let me just open this. And then let's say file new class. Yeah, you can. See, voting analyzer. And then you can add methods and then it generates the right file, CPP and header file. And it even does a hash include. You can put copy constructor, assignment operator. Again, this is actually a very sneaky way of doing it. Yeah, it's very sneaky because you can add an assignment operator and you can say that it's inheriting from another class. You can do that and then create. Okay. Okay. There we go. It even implemented the code for you. All of this. I didn't write all of this. That's the power of IDs. So yeah, man, you can also do it in code blocks, but I'm using CLion, so I'm gonna do the same procedure in CLion. I'm just gonna say create a class, give it a name, battleground analyzer. It's gonna create both the header file and the CPP file, and it will most definitely do the includes. The preprocessor directive hash include. It did do all of that. So Battleground is a kind of voting analyzer. So it's a type of voting analyzer. So I need to inherit. How do I do that? I put the column there and then I say public, right? After saying public, by public, that access modifier, it's you stating or telling the compiler what methods or variables or things that you want to access. You only want to access things that are what public. And remember, due to inheritance, when you have something that's protected, it gets translated to public. If you're inheriting from that base class, to you, it's viewed as public. So public is gonna work for both protected and public. The problem is that if you say protected, if you do this, you're only taking information that's protected. So even public information, you don't have access to it. So you can't use getters and setters. You can't use constructors from your base class. You can't do anything. You can't access anything that in your base class that's public. You can only access things that are protected. And we don't want that. We want public. Public meaning that everything that's protected and everything that's public. So it is a type of a voting analyzer. And then it's gonna moan at me. So let me hash include in the header file. Voting analyzer, there we go. It stopped moaning. So let's continue. Let's create another class, potential fraud analyzer. I'm gonna have new, then C++ class, potential fraud analyzer. Okay, let me check something. Okay, it doesn't have those. I don't know how to access those settings, but yeah, I wanted to check if it was possible for me to do the same thing and specify what's the base class. So it's a type of a voting analyzer, and then hash include voting analyzer dot h, and then this class is a latte predicted outcome analyzer. So let's also create that new class predicted outcome analyzer. There we go. It also needs to inherit public voting analyzer. It's gonna moan at me, so I need to say hash include voting analyzer. There we go. And then let me build it. Does not name a type. Yeah, that error is very common. When you get something that says does not name a type. Let me close some of these files because now I can see voting grid. Okay, there it is. So when it complains and says this does not name a type, you'd have to do what we call forward declaration. So class voting analyzer, then do forward declaration. Let's build it again and see. Does not name a type. We also need to fix that. But yeah, that's what we have so far. We'll do the rest in the next session. Yeah, we'll do the rest in the next session. So that's it for now. Let me do part 2.